Alright, so in this video we're going to talk about how to calculate the solubility product constant for a salt in pure water. So if we were to take the salt in front of us, which is obviously silver nitrate, and if we look at the reaction, we see that silver nitrate goes reversibly, as a solid, goes reversibly to a silver ion and a nitrate ion. So obviously, since this is an equilibrium reaction, we have a K. So this K obviously is going to be the concentration of the products divided by the concentration of the reactants. In this case, the products are going to be silver and nitrate, and that's going to be divided by the reactants. In this case, we have the actual silver salt. That's a 3. This is the concentration. This is a solid, right? So normally this would be fine, but there's a problem. The denominator here is actually a solid. So the thing with solids is, in terms of the equilibrium expression, the equilibrium constant expression, excuse me, is that if it's a solid or a liquid, it doesn't really, well, it doesn't really count, let's just say. And the reason why is because the concentration, if you were to take this, so for example, if we were dissolving this, and instead of having little granular, a granular sample, let's say we had something like a big block, of like salt, for example, as you would see, but instead of it being table salt, it's silver nitrate, right? So we have this big block, and we want to dissolve it, right? So we get a really big beaker, we fill it with water, and it starts to dissolve. And it's going to go based, the amount is going to dissolve is based on this K, which we actually call KSP, right? So that's the solubility product constant. So the reason why the solid doesn't actually count, and the reason why this is actually equal to the denominator is equal to 1 if it's a solid or it's a liquid, is because the concentration of silver nitrate in this block, so say if we take a little piece, right? Think about this little piece here. The concentration of silver nitrate in this little piece is not changing at all. So therefore, it's 1. But if we think about, ions, right? Obviously, if we think about ions, so for example, if we take a little space here, obviously the amount of ions are changing because it's dissolving, right? And so therefore, that's why if you had either a solid or a pure liquid, for example, water, that's why when you're trying to calculate the equilibrium constant, it doesn't factor in, because the concentration of a solid or a pure liquid is 1. So obviously anything divided by 1 is that anything. So therefore the KSP, right, the solubility product constant, which is going to govern how much is going to dissolve in, for example, pure water, is going to be just the products, right? So in this case, it's just going to be Ag plus, right, silver ion, and NO3 minus. Right, so if I know the concentration of silver and I know the concentration of nitrate ions in the solution, I multiply them together, and I can calculate the solubility product constant. And so obviously, the higher the number, the more it's going to dissolve. The lower the number, the lower it's going to dissolve. So thanks for watching this video. Hopefully this helped. We're definitely going to do some more examples on this. It's if you're just learning this, it's actually kind of confusing, but hopefully as you practice and get the hang of it, it's going to be a lot easier. So thanks for watching, and we will see you all in the next video.